let's look at finding some limits as they approach infinity or negative infinity. And for these examples, we're all going to be looking at rational functions. So you're really going to have one of three cases, and we'll see each one come up here. So the first thing I'm going to do is I'm always going to, when we're looking at a limit as x approaches infinity or negative infinity, remember we're looking at the ends of the graph. So as we get to the ends of the graph and x is getting larger and larger, right, the 9 and the negative 3 in this first example, they don't really matter because they're not going to influence the y value that it approaches as x approaches infinity. But what does matter is the highest power in the numerator and the highest power in the denominator. So notice in this instance, they're the same, right? You have 2x squared. Let's fix that 2. We have x squared over 2x squared, right? Really, there's a 1 in front here. And when that happens, all you're looking at is really it's the coefficients because even as x gets really large, it cancels itself out. So the answer on the first one is 1/2. Next one. So we've got a limit as x goes to negative infinity. But again, we're going to look for the highest powers in the numerator, and that is the second term actually, which is x squared. And then if you look here, right, it's actually written in reverse, but don't let that fool you. You still want to look to the highest power. Okay, so now I'm thinking about, okay, well, I got x squared again over 2x cubed. And when I have that, I have a smaller power over a larger power, right? And so when I have that, it means that as x gets really large, this is going to actually grow at a faster rate, and the graph is going to go towards 0 for y as x goes to negative infinity. It would be the same answer as x goes to infinity, but in this case, we're looking at as x goes to negative infinity. Okay, let's look at a couple where it goes to infinity or negative infinity. So when that happens, now look, well, let's first look at the numerator here. The highest power is negative 3x to the fifth. And in the denominator, we only have one term, and that's x squared. So we have a higher power over a lower power. And that means that as x gets really large, as it goes to infinity, it's going to grow, the numerator is going to grow faster. Okay. Now, we still need to think about, like, if I input a really large number, right, to the fifth power, well, that'll stay positive. And down in the denominator, we have a really large positive number squared. But what we do have as well is a negative multiplied by this really large number, right? So think about negative 3 times 10,000, right? That now makes it negative 30,000, right? Or even larger numbers, right, as we're going to infinity. So what it really means is there's a negative number over a positive number, and that's telling us that the graph is actually going to negative infinity. So our answer here is negative infinity. So what I'm trying to show you is that when you have a larger power over a smaller one, you always have to think of inputting either a positive or negative number, depending on if we're going to infinity or negative infinity, and that will help you to be able to figure out whether your answer is positive or negative infinity. Because we're always thinking about as x goes to infinity or negative infinity, what is y going towards? Okay, so let's do it on the last one here. Let's try this one, and we're going to have x cubed over 3x squared. So again, we have a larger over a smaller, meaning it's going to infinity or negative infinity. In this case, I'm going to think about inputting negative infinity, and I'm going to cube it, or a really large number. This is probably not the best mathematical representation, but to me, it helps me. This is my thought process. I'm just thinking about if I input a really large negative number, does it stay negative or does it turn positive? So in this case, the numerator will stay, or actually it will turn negative, and then in the denominator, it will stay positive. So that means that the answer for this one is also negative infinity. So here's your final answer on this one. So notice you have three cases. When the powers are the largest powers are the same, you have a larger power in the denominator, in which case it goes to 0, or a larger power in the numerator, in which case you just have to figure out whether it goes to negative or positive infinity.